your y-axis. So the y is technically the rise, and the x goes over. That's the vertical, or not vertical, sorry, the horizontal axes. So that's going to be paired up with your run. So what we want to do is we want to see how much is the line rising compared to how much does it run. So when I look at this, I know it's from one to the next. Well, the rise is actually going down 2 right here. And then from 3 to 1 is also down 2. 1 to -1 is down 2. You'll notice it's constantly going down 2. So when you're doing your slope, your rise, which goes along with your y's, is -2. So that's the rise part. And we want to put that over the run, right? It's rise over run, which goes along with how your x's are changing. So now I want to look at how are the x's changing. Well, the x's are just going 1, 2, 3, 4, 5. So you'll notice that they are just going up by 1 every time. So although the y's or your rise is going down 2, your run is just going over 1, +1. Okay, so then -2 over 1, since it is over 1, I can just reduce that and say -2 over 1 is the same as -2 for a slope. Okay, so when you have a slope, if it happens to make a whole number, you go ahead and make it that whole number, which is different than ones that were like 1 over 2 is a fraction. We don't usually state that as a decimal unless we're talking maybe money or something where we want to see it as a decimal. And then this one too, whenever it is improper, we do want to keep it improper because it specifically shows us rise over run. Instead of, if I mixed this up and wrote 1.5, then I would have a mixed number which wouldn't represent rise over run. Okay, so we do want to leave it a fraction unless it happens to make a whole number. And then we know whole numbers as slopes always mean over 1. Okay, so now when we write the equation for this, we would write y equals, we would put that slope, remember that always goes with the x, so the slope or the rate goes with the x, and then we need our y-intercept. So we want to look back at our table and we notice our table, or our y-intercept is supposed to be the number with 0. Well, I don't have 0 in my table. I'm looking for the y-intercept, so it's a y value whenever x is 0. So I'm going to stick a 1 right here so that I can think back and say, okay, if I have 0 there, I'd go 0, 1, 2, 3. That's still going up by 1s. I would want to see, well, what number would pair with it? Well, if these numbers keep going down by 2 every time, and I want to figure out what number came before, I would just want to see, well, what number is 2 higher than 5? And that would be 7. So your y-intercept would be 7, because then from 7 to 5 is going down 2, 5 to 3 is going down 2, and so on, okay? So 7 then is my y-intercept, okay? So my y-intercept then is the number I put in my equation, okay? So again, this is my slope, this is my y-intercept. The slope has the x, the y-intercept does not, okay? And then that is the equation of your line.